4.5 is all about our graphs of our sine and cosine functions. So just like you've always made a graph by making a table, we're going to do the same thing to make this table. We are going to use our x as our theta or our angle, negative 2 pi to 2 pi, because if you remember from when we did our unit circle, and really any circle, 2 pi is going all the way around the circle, and this gives us at least 2 revolutions around the circle to help us get our graph. So we're going to start, and if you need to draw your unit circle over here with points and whatnot, go for it. But we're just going to start our graph where theta is 0 and sine of 0 be right here. My y value there is 0. So I can put a point at 0, 0. Now before I go any further, I should probably go ahead and get a scale on my y-axis since we hadn't done that yet. We do have a scale on our x-axis, I gave you that, and a lot of the times you will keep this. Every once in a while we will change it depending on some other factors, but right now we're going to keep it. And the best way to see this graph, I think, is to let this whole, all the way to the top be 1. So this would be like a quarter, a half, 3/4, and 1. So at the very bottom is negative 1. That just will really let us see a nice pretty picture for this graph. Moving along my table, next point we're going to put in is pi over 6, because that's just the next point on our unit circle, which if you look at your unit circle or think about your unit circle, sine at pi over 6 is a half. I did change it to a decimal just because that was maybe a little easier for you to see where to graph it. Now the only issue is pi over 6 isn't actually one of my hash marks. Like this one's pi over 2 is marked. Right here is pi over 4. So pi over 6 should be somewhere over here, about right there. It's not going to be exact. That's why I made it a little bitty dot. My next point is the pi over 4. So I do at least have an exact spot for my theta. That was radical 2 over 2, which again I've changed it to a decimal because graphing radical 2 over 2 was kind of hard and confusing. But 0.707, that was 0.5. This one's 3/4, so 0.75 should probably be about right in here. Made that one a little bit darker just because it's a little bit more obvious. My next point would be at pi over 3, so now I'm a little bit past pi over 4. And it's at 0.866, so I've gotten up a little bit higher. Next point at pi over 2, which is nicely marked. That's at the very top of my unit circle. So that point up here, which was at 0, 1. So my y value, or my sine, is just 1. So I'm going to put a nice dot right there. Now as I continue through these, I know that those are the only y values that ever show up. I mean, they're negative sometimes, yeah, but these weren't very pretty to graph. So now that I have a general idea of what that looks like, I'm going to continue by just doing the ones that are going to give me either like a 1 or a 0 or maybe a negative 1, something like that, not these crazy decimals to deal with. So my next 3 points I want to plot are pi, 3 pi over 2, and 2 pi. So take a minute and fill in your table with what those sine values are, and then plot your points. If you don't have that done yet, go ahead and pause it, and then you can start back. But your 3 sine values there should have been 0, negative 1, and 0. So at pi, my point was at 0. At 3 pi over 2, you're at negative 1. At 2 pi, you're back at 0. So I have this nice S-curve, which I do apologize is very difficult to draw on the tablet that I'm using. But you can kind of see it hopefully a little bit more curved than what I have, and the more you do them, the better they'll look. This is my basic sine function. Now I can continue that and go backwards, and to do that, I'll go ahead and change to a lighter color so it stands out, but it does follow that same principle there. So I'm at 0, this went up, then down, then back up, going backwards. My 0 went to negative 1, then to 0, then to positive 1. Then down to 0, and then down to negative 1. Then up to 0, then up to positive 1, then back to 0. And if I drew this graph, Again, I'm on a tablet, which makes this very difficult. You are on paper. It should be a little bit better than this. This was awful right here. But you can always kind of smooth it out with your nice eraser. You can see how that does look like a nice fluid graph, though. Now, there are a few things that we need to look at to know, like key points and information about this graph. So I have this table over here that we're going to fill in with domain, range, period, amplitude, your x-intercepts, maximums, and minimums. So go ahead and get that table copied down, and then I'll help you fill it in. All right, so we know the domain is the x values that you could plug into sine. So we had talked about in previous lessons how when you do sine, your answer is always between 1 and -1. Here I'm talking about what you're actually plugging in to sine. So on this graph, this keeps going to the left and keeps going to the right because I could go around my circle an infinite number of times if I wanted to. So my domain is -infinity to infinity. For my range, that's what the output is. So the y values. So the lowest it goes is -1, the highest it goes is 1. And it does actually hit those points. So you're going to use brackets, -1 to 1. Now your period is like how long it takes the graph to repeat itself. I think a great way to see that is looking at from one maximum to the next. That's going to be our period. And that's from -1.5 to a +0.5 pi. So that would just be 2 pi. Yes, I can see that here as well. If I start at 0 and go to 2 pi, that gives me time for my graph to go all the way up, all the way back down, and then back to where it started, and then just repeat that cycle over and over and over. Your amplitude is actually kind of like the height of your graph. So from the center of the graph up, so my amplitude is 1. Or you could say from the center of the graph down because it does always go down 1. Your x-intercepts look like they're happening kind of frequently. It looks like they're about pi distance apart. So to write that, if I was looking at my first graph that I did, I started at 0, and then it happened again at pi, 2 pi, or -pi, -2 pi. So we're going to call that 0 plus or minus n pi, where n could be any integer. I could be 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, -10 pi. But I'm adding that to 0. My maximums happen up here at the top. So these are my maximums. If you notice they are at pi over 2, -3 pi over 2, it would continue to repeat. The distance between those two we already talked about was 2 pi. So I'm going to list pi over 2 as my starting one, since that's when I did my first period there. And then plus or minus 2 pi n. So 2 pi times any number of times. So 4 pi, 6 pi, 8 pi, negative for those as well. Minimums are also 2 pi apart, but now they're at the 3 pi over 2 and the -pi over 2. So it's going to be 3 pi over 2 plus or minus 2 pi n. This is my basic graph for sine. Moving on to cosine. You are going to do the same thing. You're going to start with your table, which in this case starts at 1. So we do probably want to go ahead and label our y-axis at 1 so we can put our nice graph there at 0, 1. And we're going to keep going. So I want you to pause this and get your points filled in. Just following along your unit circle as we did earlier. So I have my pi over 6, which should be about 0.866. So I have that dot over here roughly. Pi over 4 was about 0.707. Pi over 3 was right at a half. Pi over 2 is back down to 0. And from there, because again, I don't want to deal with these decimals, I kind of see how it's shaped. I'm going to pick up with my pi, my 3 pi over 2, and my 2 pi. So check to see that you got the same ones as me here, but I had -1, 0, and 1. So at pi, it's at -1. 3 pi over 2, it's at 0. 2 pi, it's back at 1. And just like we did for sine, we are going to go ahead and connect these graphs. Do make sure you curl it back down. Now I probably curled it a little bit sharp there, but it does keep coming down. It doesn't keep going up forever. Then you could continue it and need to continue it backwards. So it was at the top, came down to 0, down to -1, back to 0, back up to the top. That one's a little bit crooked. But there you can see my nice graph for sine. Sorry, for cosine, my fault. My nice cosine graph. Again, we're going to fill in our same table. So since you've seen me do it once, I would like for you to get your table copied down, pause this, and see what you can fill in. All right. On domain, again, it's going forever, both left and right, so that's going to be -infinity to infinity. For your range, the highest you go is 1, the lowest you go is -1, so including those with brackets, you have -1 to 1. For your period, again, I do think it's probably the easiest to look at the distance between those two maximums, but again, that is 2 pi. My amplitude would be how high it gets above the center, or how low it gets below the center, so that's just 1. My x-intercepts are happening at every like pi over 2, 3 pi over 2, negative pi over 2, 3 pi over 2. So they kind of are repeating at a distance of pi. First one being at pi over 2. So pi over 2 plus or minus n pi. Your maximums, first one's at 0. You don't have another maximum until you hit 2 pi. It does repeat that pattern. So 0 plus or minus 2 pi n. My minimums are happening at the pi and the negative pi over 2. So first one's at pi. To get to negative pi, you would have subtracted 2 pi. So again, that's going to be pi plus or minus 2 pi n. When graphing your sine and cosine functions, there's a couple of things to remember. So if you look back at your sine graph, the very first part we did in that dark green looked in general like this, which looks kind of like an S. That's how I remember that that one goes with sine. When I plot those points, I know it starts at 0 or what's going to be my middle line, because we will get to some where this is shifted up and down. I know wherever it starts, it has to end in that same spot. So I graph the first spot and then the spot where it ends. Right in the middle of those, it's back at the 0. So that's the third one I do. From there, I know it had to go up in the beginning and down towards the end. So that's the order in which I plot my points, making it kind of look like an S. Once I have that first S drawn, then just like we did earlier, and I did with that light green, you can continue the graph. For your cosine, it started at the top, went down, and then back up. Now I don't have it quite as wide as it needs to be there, but in general, that looks like a letter C. That's how I remember that it's a cosine. Yes, I know that's a U, but if you turn your head, it's a C. Kind of like with the S up here, you got to turn it a little bit. So I'm going to start at the top this time. Wherever I start, I always end there. So I go straight to the ending spot. Right in the middle, I'm now going to be at the very bottom. And then the middle of my graph is where the other 2 points are lying. So at those intercepts for 4 and 5. That's the pattern I follow when graphing these. So graphing this first one, the only thing that's different is that you have this 2 out front here. So when you graph that, that is actually going to change your amplitude. So my amplitude is 2. So all of my previous graphs, how they came all the way up to 1, now they're going to come up to 2. So when I do sine, it starts at 0, it ends at 0. In the middle, it's at 0. Between those two, it was at 1 or at the top. Now my top is 2. My bottom is -2. And if I connect those, I have a nice, rough, horrible, but nice-ish S-graph. Continue that backwards. Your period did not change at all. It still took you 2 pi to get there. Going quickly, on this one, now the 2 is inside that sine function, so that will actually affect your period. Your typical period is 2 pi. You are always just going to divide by whatever's inside that. So I'm going to divide by 2. My new period is pi, which means you have your full graph being completed by the time you hit pi.